So for this example, we want to solve the inequality algebraically. And this inequality is x cubed minus x squared minus 12x is greater than 0. And because this inequality is a polynomial inequality, we have a strategy that we go through that's a little bit different from solving a linear inequality. So first off, we want to make sure that we have all the terms on one side and 0 on the other side of the inequality. And that sets up our process for being able to pay attention to whether our expression is positive or negative. So this says greater than 0 is positive, equal to 0, and negative would be what we're not looking for. So positive is what we're looking for, negative and 0 are not. So we start with the boundary. The boundary points are where this inequality is equal to 0, where this expression equals 0. So we're going to solve that equation. X cubed minus x squared minus 12x equals 0. So I can solve this by factoring. I'll factor out an x. That would leave me with x squared minus x minus 12. I can factor some more. Get x times x is x squared. 4 times 3 is 12. If I put a negative on the 4 and a positive on the 3, that will give me the right number in the middle. And then I can set each factor equal to 0. So x equals 0 gives me one value of x equals 0. I add 4 to both sides and get x equals 4. On the equation x plus 3 equals 0, I would subtract 3 and get x equals negative 3. So you can think of these as boundary points, or if you're thinking of it graphically, these would be x-intercepts. And you're going to take your number line and you're going to put those numbers on your number line in order from smallest to largest. So that's negative 3, 0, and 4. I'm going to draw these with open circles because remember, in our inequality, we are only interested in the points that are greater than 0. So we're not interested in these boundary points because they equal 0. So then we go inside each one of these intervals and we choose test points. And we're going to test these intervals to see whether they are greater than 0 or less than 0. So I want to pick a number that's less than negative 3, like negative 4. Something in between negative 3 and 0, like negative 2. Something in between 0 and 4, like 1. And something greater than 4, like 5. And we're going to test these in our expression. So we take our test points, and we're going to plug them into our expression x cubed minus x squared minus 12x. And all we really care about is whether it comes out positive or negative. So let's test each one of these test points. Negative 4, that's negative 4 cubed minus negative 4 squared minus 12 times negative 4. Negative 4 cubed, that's going to be a negative 64, I believe. Let me just double check. Yep. And this would be a minus 16. So I carried that minus down, and negative 4 squared is a positive 16. And 12 times 4 is 48, and that's a plus 48. And so I can see that this is going to come out to be negative. So because that came out to be negative, that means that all of the y values in that interval are negative. Let's try the next test point of -2. We have -2 cubed minus -2 squared minus 12 times -2. That's a -8 minus 4 plus 24. -8 minus 4 plus 24 is going to be a positive, and so I know that this interval comes out positive. Let's try the next test point, which is 1. 1 cubed minus 1 squared minus 12 times 1. It's 1 minus 1 minus 12, and I can see that that comes out to be negative. So that means that that interval is negative. So final test point is 5. We have 5 cubed minus 5 squared minus 12 times 5. So 5 cubed is 125 minus 5 squared minus 12 times 5. So 125 minus 25, that's 100 minus 60. That's going to be a positive. So we get positive for that last interval. So once again, remember, our goal was to have positive values. So we've identified the intervals that give us positive values, and those will be the solutions to the inequality. So from -3 to 0, and I'm going to put parentheses on those ends because they produce values that equal 0. And then also from 4 on forever to infinity, 4 to infinity, and we have our solution set. All the numbers from -3 to 0, excluding the endpoints, and all the numbers from 4 to infinity, excluding the endpoints, will make this expression greater than 0.
Thank you for checking out my videos. Have a great day.